Hi, thanks for watching. I've been asked by a few people to cover air conditioners and the National Electrical Code, and it's kind of funny because air conditioners are actually, and I mean this, they are the easiest circuit in the entire code book, believe it or not. The rules in the code actually require that the manufacturer does all the calculations for you and tells you the answers, and then all you as the electrician have to do is read the nameplate and install the conductors and overcurrent protection. So it's a remarkably easy circuit, but it's very misunderstood as well. So we're going to be covering that today. My name's Ryan Jackson. This is what I do for a living. I teach seminars on the National Electrical Code, write textbooks, do expert witness work, consulting, things like that. If you have any questions or you'd like to get in touch with me, you can leave it on the video on YouTube, or you can send me an email, ryanjackson618@gmail.com. I actually want to start this discussion in kind of a strange place in the NEC, and that is 90.1b, which doesn't necessarily address air conditioners specifically, but it reminds us that complying with the code will result in a safe installation. And I need you to remember that as we go through this today. If you follow the code, it will be safe. Now, we change the code every 3 years. We know that. And sometimes we add GFCI requirements and AFCI requirements and things like that because we want it to become more safe. We find out that complying with the code was safe, but it could be safer by providing these different requirements. So we change our minds a bit when it comes to safety in the code in some areas. What we're talking about in this video is conductor sizing, and we have it figured out. Rest assured. We know what we're doing in the NEC when it comes to sizing conductors for air conditioners. It has not changed for decades. So complying with the code, if you follow the NEC for air conditioning, you will have a safe installation. I need you to trust me on that. I need you to trust the NEC. If you follow the code, you will have a safe circuit for air conditioning. It might not be efficient, convenient, or adequate for good service or future expansion, but it will be safe. Take a look at this picture I took here a couple months ago. We've got the air conditioner up here, and we've got its disconnect up there. Is that safe as it relates to the use of electricity? Sure, absolutely. That disconnect is providing fuse protection for the conductors that are supplying it. If I ever need to work on the air conditioner, I can shut it off. Is that safe? Yes. Is it convenient for an electrician that might have to bring out a ladder to climb up there to measure voltage? Maybe it's not convenient, but we never promised it would be. All that the code is promising is that it will be safe. We're not promising convenience, all right? So, yes, this is safe. It's just not necessarily convenient, but it is safe. By the way, if you're wondering, yes, that is what all of my vacation pictures look like. Went to the Bahamas, and what did I check out? Air conditioners, panels, a lot of PVC conduit. Okay, let's get into the rules. 240.3, Article 240 is overcurrent protection, and 240.3 gives us a general statement. It says conductors are protected in accordance with Article 240, and equipment is protected in the specific equipment article. All right, so the conductors supplying the air conditioner, I go to Article 240. For the equipment itself, I go to Article 440. Kind of an unusual installation here, this disconnect being mounted face down. This is actually at my in-laws' house. I was still married to my wife, but I was married to her for, probably 15 years before I ever saw that disconnect in her backyard. So, interesting installation. They're probably not code compliant. But again, the conductors are protected using Article 240, and the equipment is protected using Article 440. Protected against overcurrent. We need to understand what overcurrent is if we're going to understand the rules for protecting against it. So we go back to Article 100, one of the most important articles in the whole code that gives us the definitions. What is overcurrent? Current is current that exceeds the rating of equipment or the ampacity of a conductor. Okay, let's not go over this too quickly. Current that exceeds the rating of equipment. If the equipment is only rated for 10 amps and it pulls 15, that's overcurrent. If the wire can only safely handle 20 amps and the load is 30, that's overcurrent. So overcurrent can be from an overload, or a ground fault, or a short circuit. Any of those three creates overload, and protection against overcurrent is protection against all three of those. Let's keep going. Overload. Overload is operation of equipment in excess of its rating, or operation of a conductor in excess of its ampacity that would cause damage or overheating if it persists for a long enough duration of time. Short circuits and ground faults are not overloads. Okay, so this wire right here, I know it's a little bit hard to understand what we're looking at here, but it was a brown conductor, and you can see that it has turned into a black conductor. That was the result of overload. This was at a place where I teach, and they had to change all of their transformers. This wire has an ampacity of 380 amps, but it was pulling about 600 amps. And as you can see, it's discoloring, it's melting, its insulation is failing, and ultimately it would have caused a fire. That's an overload, right? Too much stuff on the circuit. In your bathroom, you plug in 6 curling irons and a hairdryer, you're going to have an overload. Operation of equipment in excess of its rating. This donkey here is only rated for so many boxes of whatever that is. That's an overload, right? Look, operation of equipment in excess of its rating. Or operation of a conductor in excess of its ampacity. So that's an overload. That's one type of an overcurrent. The other type of overcurrent, we have ground faults and short circuits. Let's talk about a ground fault first. A ground fault is an unintentional connection between an ungrounded conductor and normally non-current carrying metal parts or the earth. All right, we've got a metal faceplate. We can see that the hot conductor, the ungrounded conductor, has faulted to it and created a fault. That's a ground fault, right? Taking a hot conductor, smacking it into a metal part or an equipment grounding conductor. That's a ground fault, another type of overcurrent. The other type of overcurrent that we have is a short circuit. Now, this is not defined in the NEC, but a short circuit is basically a connection between ungrounded conductors of different phases or lines, or between a grounded and an ungrounded conductor. So here we have two different conductors of two different polarities, right? So two hots, phase A and phase B, line 1, line 2. And they touch each other. That would be a short circuit. Those are the three types of overcurrent conditions: overloads, ground faults, and short circuits. When we provide overcurrent protection, we're providing protection against all three of those types of overcurrent. All right, so an overcurrent protection device provides protection against all of those. And in Article 100, we have a definition for overcurrent protection device: branch circuit type. It's a device that can provide overcurrent protection for services, feeders, branch circuits with an interrupting rating that's appropriate for the installation, and it's at least 5,000 amps. All right, so 30 amp fuse here. That is an overcurrent device. 40 amp breaker. That is an overcurrent device. Both of those will provide protection against what? Against overloads, ground faults, and short circuits. It's critically important that you understand that overcurrent is any one of those three, and overcurrent protection is protection against all three: overloads, ground faults, and short circuits. Let's get into the rules. Starting with the conductors, we get into Article 240, and 240.4 is the general rule that talks about how we protect conductors. And I want to start with 240.4d, even though it doesn't apply. And I want to cover it to be very clear that it does not apply. Take a look at the first couple of words: except as allowed in 240.4e or g. Overcurrent protection for small conductors must not exceed, ultimately, for 14 gauge copper, maximum 15 amp breaker. We know that, right? 15 amp breaker, 14 gauge wire. If you got a 20 amp breaker, you got to have 12 gauge wire, copper. If you got a 30 amp breaker, you need to have 10 gauge copper, right? We know that. Now that's the general rule, except as allowed in E or G. Let's take a look at G. G talks about specific applications, and it says you do not need to follow that rule for air conditioning. So let's reiterate this. This rule does not apply to air conditioners. You are not limited to a 15 amp breaker for 14 gauge copper. You're not limited to a 20 amp breaker for 12 gauge copper. You are not limited to 10 gauge copper for a 30 amp breaker. This rule does not apply for air conditioning circuits. It doesn't, because 240.4G says it does not. We go to Article 440 for the specific rules. So we actually go to 440 to size the equipment, right, to protect the equipment. We know that from 240.3. And this section in Article 240 covers the conductors. But here it says, hey, look, 240.4, we're actually going to let Article 440 cover the conductors. It's going to cover the conductors and the equipment. All right, let's take a look at this air conditioner here. This is where people get so screwed up. I've got a fuse disconnect, and I've got my air conditioning unit. It's critical that you understand this. That fuse disconnect does not provide overcurrent protection. I know, look, it's an overcurrent device, it's a fuse, but it doesn't provide overcurrent protection, because overcurrent protection is what? Protection against ground faults and short circuits and overloads. This does not provide protection from all three. It only provides protection from ground faults and short circuits. We let the motor itself provide the overload protection. Now that's a little bit unusual. If we think of a bathroom, for example, a bathroom's a nice easy circuit, right? 20 amp circuit. The 20 amp breaker for a bathroom provides protection against overloads, ground faults, and short circuits, right? Overloads, again, if I take 5 hair dryers and 3 curling irons and plug them in, that's an overload. The 20 amp breaker trips. We know this. If I have my hair dryer and for whatever reason I got a pair of scissors and I cut the cord, right? That would be a short circuit, and the 20 amp breaker trips. Or if I had a ground fault, maybe I had my curling iron and for whatever reason I threw it in the sink while the sink's full of water and I've got copper plumbing and it tripped, that would be a ground fault, and the circuit breaker provides protection against that as well. That's how we normally do it. That is not how we do it for air conditioners. It's not how we do it for motors. It's not how we do it for feeder taps. It's not how we do it for transformer secondary conductors. For those 4 circuits, we do it this way. We provide ground fault and short circuit protection upstream. We provide overload protection downstream. Okay? So I need you to understand that. Overload protection is done by the motor. Ground fault and short circuit protection is done by the fuse disconnect or the circuit breaker in the panel if it's a pull-out disconnect. Overload protection at the motor, ground fault short circuit protection upstream of it. Getting into the rules in Article 440. This is one of the best rules in the entire code. 440.4b, multi-motor and combination load equipment. That's an air conditioner, right? It is a combination load. It has the hermetically sealed motor and it has the fan. So it's a combination load, Article 440. It says the nameplate must include the minimum conductor ampacity and the maximum overcurrent device rating calculated using parts 3 and 4 of Article 440. Awesome. The code just said the manufacturer has to do all the math and they have to tell you what the answer is. It seriously says that in the code. 440.4b says the manufacturer has to do the math and they have to tell you the answers. And that's why it says on your nameplate minimum circuit ampacity, and sometimes it will tell you the minimum fuse or breaker, but it has to say the maximum fuse or breaker. And all you have to do, this is so much easier than you think, all you have to do is get a wire that satisfies the minimum circuit ampacity and a breaker or fuse that is not larger than the maximum breaker or fuse. That's it. That's all you have to do. Let's do one here, for example. This is 440.21, but in all honesty, you don't even need to read this in the code. All you need to read in the code is 440.4b and know that the manufacturer has done it all, and then you just go off the nameplate. You really don't need to read anything else in Article 440. But, a lot of people want to know this, so air conditioners must be marked with the minimum circuit ampacity and the maximum overcurrent device. These numbers are calculated using Part 3 and Part 4 of Article 440, 440.21 for the branch circuit, ground fault, and short circuit protection device, so the fuse or breaker. All right, let's look at this piece of equipment. The minimum circuit ampacity is 21 amps. Maximum fuse is 30. Okay, now this is an easy one. I need a wire that can carry 21 amps. Now, by the way, we're going to be using the 60-degree column of table 310.15b16. We're going to assume that we're using NM cable, which is limited to the 60-degree column. That's 334.80. Or we're just going to say, look, this isn't marked with its terminal ratings, and 110.14C2 says C1 says that if it's not marked, you have to use the 60-degree column. So let's use the 60-degree column. I need a wire that can carry 21 amps. 60-degree column, 12 gauge isn't going to do it. 12 gauge is only good for 20 amps. So I need 10 gauge, right? I need 10 gauge wire because that will carry 21 amps. And then all I have to do is I go off of the nameplate, 30 amp fuse, done. That's it. All right? Now, are you comfortable with that? Are you comfortable putting 10 gauge wire on a 30 amp breaker? My guess is yes. We've done it, thousands of times throughout our career, putting 10 gauge wire on a 30 amp breaker or fuse. Let's keep going and do one more example. Here we've got a unit. Minimum circuit ampacity, 14 amps. Maximum fuse or breaker, 25 amps. Okay. We are going to use a 25 amp breaker. Period. All right. By the way, we have to use at least a 20. If we don't use at least a 20, then the breaker will trip before the unit starts, and that's a code violation, right? If we put it on, could we put this on a 10 amp breaker? No, because the motor won't start. If the motor starting trips the breaker or smokes the fuse, that's a code violation. We have to let the motor start. So there is a minimum. It has to be at least 20 amps, but it can't be more than 25 because we have to provide protection. We're going to use a 25 amp breaker. All right, that's not subject to debate. That's what we're doing. We're using a 25 amp breaker. I don't have any 20 amp breakers in the truck. We're using a 25. I need a wire that can carry 14 amps. 15 amps, 14 gauge. Beautiful. I'm going to put 14 gauge on a 25 amp breaker, and it is going to be perfectly safe. You want to know why? Because the code says in 90.1b, if you follow the code, nobody's going to die. For a fact, this has been allowed for decades. Now I'm going to explain to you why it's allowed. A ground fault and a short circuit, right? Taking two wires, jamming them together. If I have 14 gauge wire, and I take the black and the white, and I smack them together, I have a short circuit, right? 240 volts, line to line. If I have a short circuit, is that going to trip the 25 amp breaker? Absolutely. If it's not my lucky day, it will blow the 400 amp main. It will absolutely trip the 25 amp breaker. So we have ground fault and short circuit protection. We have to agree on that, right? We know it has ground fault and short circuit protection. But that's not all when it comes to overcurrent protection. We have to have overload protection as well. If I put 14 gauge wire, which is good for what? 15 amps. If I put a 15 amp rated wire on a 25 amp breaker, how is that protected against overload? What happens if, what if the shaft on the motor gets bent? A tree comes and hits the air conditioner and it jacks it up, right? So now all of a sudden the motor is struggling and it starts pulling 18 or 19 amps. Well, that 14 gauge wire is going to melt, right? Actually, it's not. Do you want to know why? The motor will shut itself off. The motor has built-in overload protection. The motor will not continue to run at greater than about 14.9, 15 amps. It will just shut itself off. Have you ever had in your house, have you ever had at your disposal, you ever had to open up the cabinets, reach under there, and push the button on your disposal because food or something got caught in the blades? That is built-in overload protection. That motor stopped spinning because food got caught in it, and it was trying too hard, and it was starting to pull more current because it's basically like under a locked rotor condition, so it's starting to pull more current. and the wire's going to melt and the motor's going to break. So you know what the motor does? It just shuts itself off. Before it can fail, it turns itself off. And that's why you have to reach in and manually, you get in there and you get the food out or the fork or whatever, then you reach under it, you push the button, and everything's back to normal. It's the same thing with an air conditioner motor. You reach into the motor or you pull the tree out or whatever it was that's creating the overload condition, right? And then you turn it back on and everything works fine. You have ground fault and short circuit protection. You know the 25 amp breaker is going to trip if I take those two 14 gauge wires together. And if it starts pulling more current than the ampacity of the conductor, it will shut itself off. It's thermally protected. It's inherently protected. So that's why I can use 14 gauge wire on a 25 amp breaker for this particular unit. We can do another example if you want. This unit has a minimum circuit ampacity of 29 amps. Okay, now let's just stop. We know, or at least we should, the minimum circuit ampacity and the maximum fuse or breaker size have nothing to do with each other. Absolutely nothing. Okay, so let's size the wire first. I need a wire that can carry 29 amps. Well, that's 10 gauge. For a fact, we are going to use 10 gauge. All right, we will use 10 gauge for this motor. What size fuse or breaker should I put on it? Just erase from your mind the fact that we're using 10 gauge. It doesn't matter. It doesn't matter what size of wire we're using. When it comes to sizing the ground fault and short circuit protection device, that is a completely unassociated different animal. So we're going to use 10 gauge, fine. Write that answer down, put it away. When it comes to sizing the fuse or breaker, maximum fuse is 50, perfect. 50 amp wire, or excuse me, 50 amp breaker, 50 amp fuse, that's what we're going to use. Can you put 10 gauge wire on a 50 amp breaker? Not in most instances, but you can for air conditioners. Why can you do that? Because if you take two 10 gauge wires and you short circuit them together, if you take two 10s, the black and the red, and hit them together, or the black and the white and hit them together, or the red and you bang it into the disconnect enclosure, is that going to trip a 50 amp breaker? Absolutely. It will trip it in like one cycle, 1/60th of a second it will trip. What's protecting that 10 gauge wire from melting due to overload? The motor itself. It's thermally protected. It's built into the unit. That is why you can use a smaller wire and a larger fuse or breaker when it comes to air conditioning. All right. If you have any questions, leave them on the video on YouTube. Go to my Facebook site, Ryan Jackson Electrical Training, or even email me if you want to, ryanjackson618@gmail.com. I hope you got something out of this video. Take care. Be safe.